Today we will be working with getting the message from the user and converting each character that the user typed in into bits and bytes. And then with these bytes we can convert them into emojis using a function that CS50 gave to us. Hi everyone, my name is Giovanna Proença and today we're going to talk about problem set 2, this new problem set here that you're seeing in the screen. Basically, in this problem, we have to get the message from the user, and we're going to use the getString method, and we're going to convert each character of this message into bytes. And then with these bytes, we're going to convert them into bits, and then we're able to get the zeros and ones that we saw during the lecture. So today we're going to work as well with binary digits. And then once we get these zeros and ones, we're able to display an emoji that will simulate light on or off. Okay, so let's see what we have so far. Basically, this is the code that CS50 gave to us. We have here this const int bits in byte equals to 8. So here we're assigning that there are 8 bits in a byte. All right, we have a prototype of our function printBulb. And here we're expected to receive an integer called bit. And then we have our main function where we're going to implement this, and let's see what we already have. So basically CS50 already implemented here this function for us that is returning anything. And as I mentioned, we're going to receive 1 bit. So here the only thing we have is if bit is equals to 0, we're going to display this dark emoji, so it will be off light. And otherwise, if the bit is equals to 1, we're going to display a light emoji, so it will be a light on. All right, our goal here is to get the user data, the user input, and convert each character into these bits. Okay? To do this, let's understand how we're gonna do this problem by watching this animation. A light bulb can only be in one of 2 states, on or off. A binary digit can only have 2 possible values, 1 or 2. This is a fundamental concept in the way computers store and process information. Our code will take the message entered by the user and convert each character of the message into an 8-bit binary number. This means that each character is represented by 8 binary digits or 8 bits. This is known as encoding the message into binary. By doing this, computers can understand and process human language, and we can communicate with machines in a way they can understand. So the code will take a message string and transform it into a sequence of ones and zeros, which is the binary representation of the message. Then the function printBits, written by CS50, will convert the binary digits into emojis. So now that we saw this animation, let's start from the beginning. Okay, let's do what we know for now. So we know how can we get the message from the user. Okay, so this will be the first thing we're gonna do. We're gonna use our getString method to get this message. So here we know that the input will be a string, and I'm gonna create a variable here called message, for example. And I'm gonna use the getString function. And here I wanna display a message saying message. That's pretty much what we're gonna do. Okay, and if we take a look in here, if I do cd CS50 week 2 bulbs, here we're able to see what's going on. If I make bulbs, and then if I run our code doing ./bulbs, we're gonna see this message displaying this message. If I put here CS50, nothing will happen because so far we're just asking the user for this message. Okay, now we need to loop through this string, and we're gonna take care of each particular letter that we're receiving in this message, because each letter will contain a different zeros and ones that we're gonna represent. All right, so to do this, how can we loop through our string? We're gonna do a for loop, and we're gonna use the length of the string as our limit. Okay, so here I'm gonna do for int I equals to 0, I less than starlen. Remember that the starlen function is a function from our string library where we can get the length of our string. And here, what is the name of the string? Is message. And I'm gonna do an I plus because I want to always update the value of I. So now that we're looping through each letter here in our message, we need to take a look here at what CS50 tells us. So basically the first step consists of turning the text into decimal numbers. Let's say we want to encode the message hi. Luckily we already have a conversion in place for how to do this, that is using the ASCII table. So we know here when we're looping through each letter in our So we know that when we're looping through each letter of our message, we're gonna get the letter, but not only the letter capital H, for example. We're gonna get the number 72, that is the decimal number for this letter. Okay, so this is great. We are already doing this loop to get this number. Then our next step, we're gonna take the decimal number, so 72, and we're gonna convert it into binary numbers. So we're gonna convert 72 into zeros and ones. And to do this, it's important to understand how can we do this conversion. So let's see this animation. The conversion from character to binary can be achieved through a loop that repeatedly divides the decimal representation of the character by 2, stores the remainder and the quotient, and repeats the process until the quotient is 0. The binary representation is then obtained by reversing the order of the remainders. Let's suppose we want to convert the number 10 into binary. First, we will divide the number 10 by 2, the quotient is 5 and the remainder is 0. Since the quotient is not 0, we will divide it by 2. This will give us a new quotient 2 and remainder 1. Again, since the quotient is 2 and it's not 0, we will divide by 2. This will give us a quotient 1 and remainder is 0. Since 1 is not equals to 0, we will divide 1 by 2. This will give us a quotient of 0 and remainder 1. Finally, we finish our divisions and we know that the binary number is all the remainder together organized in reverse order, which means the binary representation of 10 is 1010. So as we saw in the animation, we're gonna get the number in the ASCII table for each letter, for example 72 for high, and we're gonna keep dividing this number by 2, and we're gonna get always the remainder to know what is the binary number we're gonna add. Okay? Before we start everything, let's get the ASCII number for each character. So how can we do this? We're gonna create a variable called unsigned char, and I'm gonna give the name byte. Okay, and now I'm gonna get the ASCII table. So for do this, how can we access the letter of our string? We're gonna say the name of the string on position I, okay? Then I wanna create an array to store all the binary numbers. And here in CS50, they mentioned that our binary number will be represented with 8 bits. So we're gonna create an array with 8 elements that will store the 8 bits, so the 8 binary numbers to create our number in here. So 8 zeros and ones, okay? So here I'm gonna create a variable, an array called binary, and I'm gonna give the length of this array bits in byte. So here bits in byte. Oops. Okay, and I'm gonna initialize it with any value. Then what are we gonna do? I'm gonna create a variable called quotient, and the first value of our quotient will be our byte. Okay, so 72 for the letter H, capital H. And we're gonna change this quotient with time, okay, don't worry. So here I'm gonna do int quotient equals to byte for now, okay? And finally, I wanna initialize our variable remainder with no value, but this way we can use in the future, okay, remainder. Now, as we saw, we need to convert our decimal number into binary. And to do this, we're gonna follow that steps that we saw. We're gonna keep dividing our number by 2. Okay, so here I'm gonna do a for loop, and one thing that is important. As we know, 1 byte contains 8 bits. So we're gonna do 8 iterations in here, 1 for each bit that we're gonna add in here. So I'm gonna do an int j equals to 0, j less than bits in byte, that is the variable that is storing the value 8, j plus plus, okay? And what are we gonna do in each iteration? We're gonna divide the number that we have in here by 2. So first I'm gonna get the remainder of this division. So how can we get the remainder of the division? We're gonna use the modulo operator. So I'm gonna do quotient modulo 2, okay? This way we're gonna get the remainder. So we're gonna get 0 or 1. And then we need to add this remainder in our binary array. So here I'm gonna do binary on position j will be equal to remainder. So this way we are storing by the bits of our number. So for 72, we're storing here the zeros and ones to complete it. And finally, we need to actually divide the quotient by 2. So far we were working with the remainder, now we're gonna update the value of quotient. So here quotient is divided equals to 2, okay? This is pretty much what we have to do. We're gonna see in a bit how this is working with the debugger, but so far this is the representation of what we saw in the animation, okay? So now, our goal is to, now that we have all their zeros and ones, we're gonna call the function printBulb to display the dark or light emoji, okay? And one thing that is important to notice, if you remember from the animation, here, this thing that we're doing, dividing the number by 2, getting the remainder, will give us the reverse order of the actual binary number for the character we're working. So now to call the function printBulb, we have to call it backwards. We're gonna do a backward for loop. Instead of starting from 0, we're gonna start from 7. That is the last bit we have in our byte. So here I'm gonna do for int k equals to bits in byte minus 1. This will give us the number 7. K greater or equals to 0 and k minus minus. So this way we're starting at 7 and we're gonna finish at 0. We're doing this backwards.